Okay, today we are going to use similar triangles to indirectly measure things that might be too tall or too far away to actually measure with the tape measure. And so when we do these they're word problems. There are three kind of pictures that we can draw. Okay, most common I think will be these two separate triangles. Okay, where we've got two objects that are completely independent of one another. And we'll do a couple examples of these here. Two triangles that are mirrored. Okay, and then here where we've got a big triangle, and then a smaller triangle inside that big triangle. Okay, so we're gonna do 4 examples. At the very least, you need to draw these triangles. Okay, I'm gonna add some fun art to them, but you don't have to do that. Okay, just like the trig problems, when we were doing the trig problems, you don't need to be extra. Okay. So example 1 here says a tree outside of Ellie's school building casts a 125-foot shadow. Okay, now if you think about your real life, shadows fall on the ground. Okay, so the shadow will always be a horizontal distance. Okay, and here's our tree. Okay, at the same time of day, that's important. The same time of day means that these angles here are congruent, which then would make these triangles similar by that angle similarity. Okay, but Ellie's shadow, so here's Ellie. Okay, her shadow is 5.5 feet long. Okay, if Ellie is 4'6", how tall is the tree? Okay, now we've got to be careful with this because 4'6" is not 4.6. Okay, 6 inches out of 12 inches is 1/2 of a foot. So Ellie is 4.5 feet tall, and we don't know how tall the tree is. That's what we're trying to find. Okay, so we are using the information in these word problems to set up a pair of similar triangles, and then we will set up a proportion and solve that proportion. Okay. It doesn't matter which triangle you start with, okay, but remember, just like we practiced in class on Monday and Tuesday, we have to go the same direction, okay? And so I'm going to go from the tree, the triangle that is dealing with the tree, to the triangle that is dealing with Ellie. Okay, so if I say x over 4.5, which is the height of the tree over the height of Ellie, has to be equal to how long the tree's shadow is over how long Ellie's shadow is. Okay, so I've got those corresponding parts matched up. And now I'm going to cross multiply. So when I do 5.5 times x, that's 5.5x. 125 times 4.5 is 562.5. And then I divide. And my x value ends up being 102.2727, blah, 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 blah. Okay, so if we get a decimal like that, we are going to round to 2 decimal places again. Okay, so 102.27, and then we need to include a unit because we're talking about a distance or a height or a length. Okay, so based on this information, this tree is 102.27 feet tall. Okay, number 2, Katie places a mirror down 15 feet from the bottom of a flagpole. Okay, so let's use purple. Here's our flagpole. And this here, where the two triangles are touching, is our mirror. Okay. She placed the mirror down 15 feet from the bottom of the flagpole, and then she walked back another 10 feet. Okay, so here's Katie. When she looks down at the mirror, she can see the top of the flagpole in the center of that mirror. Okay, her eyes are 5 feet 3 off the ground. Okay, and again, we've got to be careful here. 5 feet 3 inches is not 5.3. Okay, 3 inches out of the 12 inches is 1/4 of a foot, 0.25. Okay, so Katie's eyes here are 5.25 feet off the ground. Okay, and again, we want to know how tall is the flagpole. So we've got our similar triangles set up. Okay, there are many, many ways to set up a proportion. Okay, but the important thing is you're matching not only the corresponding sides in one direction, but also which triangles they're coming from in the other. Okay, so here 5.25 and X are both representing a height. Okay, now 5.25 came from the left, came from Katie's triangle. X came from the flagpole triangle. So I've got to keep that consistent in my second ratio. Okay, so I need to say 10/15. Okay, I've got my proportion set up, so I'm going to cross multiply. When I multiply 15 by 5.25, I get 78.75. And then divide both sides by 10. My X value is 7.875. Okay, so this flagpole is about 7.88 feet tall. Not a terribly tall flagpole, but you know, that's okay. All right, number 3 is an example of our big triangle to small triangle. Okay. So first, let's use blue this time. Okay, here's our building. The building is going to represent the big triangle, okay? And you are going to represent the small triangle, which logically that makes sense, okay? So you notice somehow that a building's shadow is 400 feet long. So from the building to the end of the shadow is 400 feet. All right. You walk 390 feet away from the building so that the ends of your shadow meet, okay? And what that does here, that means that this angle is a part of both triangles, so that's our angle-angle similarity there, okay? But if you walk 390 feet away from the building, that means that there are 10 feet left between you and the ends of the shadow. Okay, 400 minus 390 is 10. All right, you are 6 feet tall. Okay, and we want to know, how tall is this building? Okay, so if we look at big triangle to small triangle, all right, the height of the building over the height of you is going to be equal to the length of the shadow of the building over the length of my shadow, or your shadow, which was 10 feet. Okay, and if it's helpful, after you get the big picture labeled, if you need to separate the triangles, so here we have our building, and we know this is 400, this we're trying to find, and then our triangle is a small triangle, 6 and 10. You can separate those two triangles so it turns in, so you can see the two triangles individually, okay? But here we're going to cross multiply. We've got that proportion set up. 10x equals 2400. And when we divide both sides by 10, x is 240, which means that our building is 240 feet tall. Okay. Last example here. We're going to go back to those two separate triangles. All right. Ryan is playing basketball outside one day. The backboard of a basketball hoop is 13 feet high. Okay. So here's our basketball hoop. Okay, but we know, let me use a different color to write that. Height. So we know that's 13 feet high. Ryan here is 6 feet tall. Okay, and his shadow is 9 feet long. Okay, how long is the basketball hoop's shadow? So now instead of trying to find how tall something is, we're trying to see how long this shadow is. Okay. Again, it doesn't matter which direction you go when you're writing your proportion. You can go from hoop to Ryan or the opposite way. Okay. Personally, I like going left to right. So since this basketball hoop triangle is on the left, I'm going to start with 13. So the height of the hoop over the height of Ryan equals how long the hoop's shadow is, which we don't know, over how long Ryan's shadow is. Okay, so we've got our proportion set up. We're going to do cross multiplication. So 6 times x is 6x. 13 times 9 is 117. And now we divide both sides by 6. X ends up being 19.5. So that means that the basketball hoop shadow is 19.5 feet long. Okay, now your job is to come up with your own indirect measurement problem and submit a Flipgrid video.